Good evening, friends. Today we will discuss about series. In reasoning questions, every time in the IBPS or PO or in all these exams, we see a lot of series questions. Generally, we'll get at least around 5, 6 series questions. A lot of students are getting confused by these series questions. These are very easy. I'll tell you some tricks by which you can solve any of these series questions. There are some patterns. We should understand what are those patterns, and then just by looking at the question, we'll be able to spot the answer. What exactly is happening in the series? These are very logical. I'll tell you how to attack these problems. Let's take one few examples. First example is this: 10, 15, 24, 35, 54, 75, 100. Okay. Let's look at this case. Uh, let's look at this differences. 15, 5, 9, then 11, then then 19, 21, and 25. These are the differences. If you can see 5, 9, and then there is 11 and 19. Then there is 21 and there is 25. It looks like something is increasing by 4. 5, 9, if this was 13, and then this number would have been 37. And then 37 plus 17 plus 17 would have been 54, right? So looks like this number, the goal was to find which number was wrong. Looks like there is something wrong with this number. 10 plus 5 equal to 15. 15 plus 9 equal to 24. 24 plus 13 37. 37 plus 17 equals 54. Everything is increasing by 4 each, right? 54 plus 21 equal to 75. 75 plus 25 equals 100. Everything is increasing by 4 each. The addition which we are doing is increasing by 4 each. Now, let's look at this series again. 10, 15, 24, 35, 54, 75, 100. Here you can see even numbers, right? You can see even numbers. And you can see odd numbers also. When a series is moving between even and odd, even, any number into even will always result in even, right? Even slash odd. For example, 2 into 2 or 3 into 2. Both will result in even. Okay. So even multiplication will always result in even. Odd multiplication, odd into odd is odd. Even into odd is even. That we all know, right? Now here, both in the series, even is also coming, odd is also coming. What does that mean? It's not, there is no multiplication definitely. If there is a multiplication with even, then the series will always be even. If there is multiplication with odd, depending on it, it will not be alternating, right? But one odd addition. So, for example, let's start with 3. 2 plus 3 is 5. And again, you do plus 3 is 8. 8 plus 3 is 11. 11 plus 3 is 14. Right. Odd addition will give even and odd, right? Even and odd. This we have seen. That odd addition will give even and odd. Whereas even addition will not change. 2 plus 2 is 4. 4 plus 2 is 6. 6 plus 2 is 8. It will not change. Similarly, 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. If it is odd addition, it will all remain odd, depending on what is the original number. If it is even addition, it will all remain even. All remain even. Right. Depending on what exactly is the original number. If even addition, whatever is the original number, it will remain even. In this case, it is remaining even. In this case, it is remaining odd. Okay. But in case of odd addition, 2 plus 3 is 5. 5 plus 3 is 8. See, odd addition, odd addition will make the series even and odd. We will see odd numbers and even numbers only in case of odd addition. Right. Not in even addition, not in even multiplication, not in odd multiplication. If numbers are going or shifting between even and odd, that means there must be definitely some kind of odd addition. Some kind of addition. Most probably it is odd. In this case, 5. So now then we have to look at how fast the series is growing. The series is not growing very fast. Right. The growth of the series is growing normally only. This number is not 2 times or 10 times or 15 times, etc. So these are a few checks that we have to see while understanding a series. Let's look at more examples, then you will understand. Right? Let's look at a second problem. 1, 3, 4, 7, 11, 18, 27, 47. We have to understand what exactly is the mistake here. See, the series is not growing fast. Not growing fast. Right. That means there is no multiplication. No multiplication. If there's a multiplication, it will grow faster. Right. There is must be some addition. Let's look at what is happening. 1, 3, 4, 7. The addition is not constant. Here there's a difference of 2. Here there's a difference of 1. Here there's a difference of 3. Here 4. Here 7, etc. Now if you see 1, 3, 4, 7. This is the same as this 1, 3, 4, 7. This is called Fibonacci series. Fibonacci series. Every number is the sum of previous two numbers. So, for example, 1 plus 3 is 4. 4 plus the previous number is 7. 7 plus 7 plus 3, 7 plus 4 is 11. 11 plus 7 is 18. 18 plus 11 is should be 29. This is not 29. So this is the mistake. It should have been 29. Right. 29, then 29 plus 18 is 47. This is the correct series. So now we have identified, no? This is called Fibonacci series. Fibonacci series. By the great mathematician Fibonacci. He was in the earlier around 1100 or so. This is a mathematician at that time. I think he was the Italian mathematician named after him to the series. Fibonacci series. Right? We learned about simple addition, and in both cases it is simple addition only, and learned about Fibonacci series. Let's take another problem. 3, 2, 3, 6, 12, 12, 37.5, and 15.5. Let's take this one. There are 0.5s. That means a number is becoming 0.5. That means there must be some multiplication or addition or both with some kind of 0.5. Otherwise, you can't make a normal number as 0.5, right? 3, you have to make it as 2 using some kind of 0.5. If you look closely, 3 into 0.5 plus 0.5. How much is this? 3 into 0.5 and 0.5 plus 0.5 is 2. Similarly, 2 into, then 2 and 3. How do you make 2 as 3? 2 into 1.5 is 3, right? Otherwise, there is no way to make 2 as 3, or 2 into 2 minus 1. There are various ways to make 2 as 3, right? 2 square minus 1, or 2 into 1 plus 1, or or 2 into 2 minus 1, like this. But in this case, we want some multiplication and some addition. So 2 into 1 plus 1 is becoming 3. Right. Now 3, how do you make it as 6? 3 into 2 is 6. There is another way. 3 into 1.5 plus 1.5. 4.5 plus 1.5. This is also 6. Similarly, 6 into 2 is 12. 6 into 2 is 12. But look at the series. 0.5 plus times 0.5 plus 0.5 into 1 plus 1 into 1.5 plus 1.5. It should have been into 2 plus 2. It should have been 14. Okay. Similarly, 14 into 2.5 plus 2.5. How much is this? 14 into 2.5. How will you do this? It is 35. 35. How will you do this? 35 plus 2.5 is 37.5. 14 into 2.5. I'll give a small trick. 14 into 2.5 is equal to 14 into 5 by 2. Right, 2.5 is 5 by 2. So this is 7. 5 sevens, 35. So you need to learn how to do this kind of fast calculations. Right, 14 into 2.5, you should quickly identify it as 35 just by looking at it. Right, 35 plus 2.5, it is 37.5. Right, now understood this problem, right? So here, instead of 12, it should have been 14. That is the correct answer. Now let's take another example to cover another concept. 4, 2, 8, 32, 148, 765, 4626, etc., etc. This series, like you see, it is growing very fast. This is kind of 4 times, and this is also kind of 4 times, and this is kind of 5 times. This is kind of 5 times, and this is 6 times, 7 times, etc. It is going very fast. It's actually growing, and you can see 32. There is some odd number also in between. Means probably there must be some addition, right? So now 8 fours are 32, right? It is growing kind of 4 times, but it is growing more than 5 times, or around 5 times, right? This is around 4 times. This is also around 4 times. This is also around 5 times. This is also around 5 times, 150s, right? Or 750. Okay. This is also growing more than 5 times. Now let's look at this carefully. And we have an odd number also in between, right? 2, how do you make it as 8? 2 into 4 is definitely 8, or 2 into 2 plus 2 square. This is also 8, right? Now 8, how do you make it 32? 8 into 4, or 8 into 3 plus 3 square. This becomes 33. We don't know whether 33 is right or 32 is right. Let's see. Let's try this. 22 plus 2 square is 33. Now 8. Now 33 into 4 plus 4 square. Let's try this out. Is 148, right? And 148 into 5 plus 5 square. 148 is by how much? This is equal to 765, right? 148 into 5 is equal to 150 into 5 into 5 minus 10, right? How do you do this? Is equal to 750 minus 10. equal to 740. 740 plus 5 square equal to 765. Just by looking at 148 into 5, you should mentally do it. 148 into 5 is equal to 125 minus 10, which is equal to 740. Okay, just by looking at this, it is 740 plus 5, it is 765. Similarly, 765 into 6 plus 6 square, 765 into 6 is how much? So what you will do, this is 7, sorry, this is 700 into 6 plus 65 into 6. Right, what is 700 into 6? 4200. 65 into 6 is how much? 390. How do you do this? 65 into 6. 66 is 360. 76 is 420, somewhere in between, which is 390. This is 4590. That's right. 4590 plus 36 equals 4626. Right. So now what is the problem here? 33 is the wrong number. Understood? It is the series is a beautiful series. Into 2 plus 2 square, into 3 plus 3 square, into 4 plus 4 square, into 5 plus 5 square, into 6 plus 6 square. You need to closely observe because the numbers are growing very fast. That means there must be some multiplication, and there are even and odd. That means there must be some addition. There's an addition in them, there's a multiplication involved because the numbers are growing fast and the numbers are going between even and odd. Hope you understood this basic concepts. We covered four important series. We'll cover many more. Just practice. I'll tell you a lot of tricks. But we'll cover more in the next video. Thank you. Bye bye.